Good day, this is Professor Will, CPMD, PhD, and today's Monday, November 22nd, 2021. It is 10:21 and 44 seconds, p.m. Eastern Standard Time. And today's research, diabetes treatments. So let's hop to it here. Venom to cone snail could lead to future diabetes treatments. Date November 18, 2021. Source, University of New Hampshire. Researchers have found that variants of this cone snail venom could offer future possibilities for developing new fast-acting drugs to help treat diabetes. The tapered cone shell is popular among seashell collectors for its colorful patterns, but the smooth mottled shells are also home to the cone snail, which is capable of spewing a potent insulin-like venom that can paralyze its prey. Diabetes is rising at an alarming rate, and it has become increasingly important to find new alternatives for developing effective and budget-friendly drugs for patients suffering with the disease. The research work found that the mottled cone variants, or analogs, bind even better to receptors in the body than the human hormone, and may work faster, which can make them a favorable option for stabilizing blood sugar levels and the potential for new therapeutics. The researchers looked more closely at the cone snail venom, which induces a hypoglycemic reaction that lowers blood sugar levels. Unlike insulin made in the body, the venom's peptide sequence, which allows it to bind to human insulin receptors, is much shorter. And to test whether it would still bind effectively, the researchers used sequences of the insulin-like peptides and the venom of the cone snail, Conconus geographus, as a template to model 6 different conelin analogs. The newly created variants were made up of much shorter peptide chains than human insulin, lacking the last 8 residues of the B chain of the human insulin. And to study the stability and variability of the new conelin structures, they conducted multiple independent computer simulations of each conelin variant complex with human insulin receptor in a near physiological environment, accounting for water solvent, salinity of solution, temperature, and pressure. They found that each insulin complex remained stable during the simulations, and the designed peptides bound strongly, even better than the naturally occurring human insulin hormone. The interactions were then compared with the human insulin receptor, and it was determined that each conelin variant exhibits few feasible residue substitutions in human insulin. While more studies are needed, the research shows that despite the shorter peptide sequences, the cone snail venom can be a viable substitute, and researchers are hopeful it will motivate future designs for new fast-acting drug options. The insulin-like venom released by certain cone snails can be highly dangerous, causing a hypoglycemic shock that immobilizes fish and potential prey. The Conconus geographus has the most toxic snake known among the species, and there have been reports of human fatalities, especially to unsuspected drivers who are not aware of the snail's venom. Good day, this is Professor Will, CPMD, PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.